Hello everyone. Today I will be talking about mixture of expert as part of the Deepseek. What is that evolution, and what is the change in the technology, and how efficiently we can use this technique for getting as part of AI techniques, or Gen AI a perspective, or retrieving relevant information and from the trained trains or the sources which are trained, and how effectively we can get the relevant information. Having said that, I would be going in detail about mixture of expert first. A mixture of expert at the model operates on this principle by dividing complex tasks among smaller specialized network known as expert. So each expert focus on specific aspect of problem, enabling a model to address the task more efficiently and accurately. So it focus on one particular aspect. Example: a doctor for medical issues, a mechanic for car problem, a chef for cooking. So he will, specifically focus on that particular area where he's having that expertise. Specialist can solve broader range of problem more effectively and than a single generalist. How the typical flow of the information, or as part of this MOE, a mixture of expert, uh, input is provided. This is uh, this is the problem or data I want to AI to handle. Input expert, these are the smaller AI modules, each trained to be really good at a specific part of the overall problem. Think of um, think of them like different specialists on your team. Getting network. Uh, this is like a manager who decide which expert to best suited for each part of the problem. It looks at input and figures out who should work on what. Then output. This is the final answer or solution that the AI model produce after expert had have done and done their work. So this is the flow. Typically input, and then particular expert, and getting by getting network generated by the getting network. Based on that, the output is provided. Moving on, MOE divides the task among smaller specialized expert network, each focus on specific domain or subtask. A crucial component of MOE is gating network. This acts like manage or dispatcher deciding which expert is best suited for a given input. It analyzes the input and intelligently route it to the most relevant experts, and ensuring efficient and accurate processing. MOE model can be implemented in various ways, including hierarchical mixture of expert, uses multiple levels of gating network in in tree like structure, with expert residing at the leaf node. The hierarchical approach allows more complex and nuanced decision making, further enhancing the model of ability to handle diverse tasks. Furthermore, MOE architecture enables larger scale models to reduce computation cost during the pre-training and achieve faster performance during inference time. This efficiency stems from selective activating only the specific expert needed for a given task rather than activating the entire neural network for every task. Advantage of using MOE is its more efficiency. Only the expert at who are good at particular part of the problem are used, saving time and compute power. Flexibility perspective, you can easily add more expert or change in their specialties is making a system adaptable to different problem, making the system and adaptable to different problem. Better results, and because of each expert focus on what they are good at, the overall solution is usually more accurate and reliable. Benefit of mixture of expert. A mixture of expert architecture offers several advantage. Performance perspective, by selective activating only the relevant expert for a given task, MOE models avoid unnecessarily competition and leading to improved speed and reduced resource competition. Flexibility, the diverse capability of experts it make MOE model highly relevant, highly flexible by calling on expert with specialized capabilities. The MOE model can succeed in wider range of tasks. Then fault tolerance, MOE divides, right, the divide and conquer approach. Then scalability perspective, decomposing a complex problem into smaller, more manageable tasks helps MOE model handle increased complicated inputs. Application of mixture of expert. In case of natural language processing, MOE offers a unique approach to train large models with improved efficiency, faster pre-training, and competitive inference speed. A traditional defense model, all parameters are used for all input, especially sparsity. However, allows the model to run only specific part of system based on the input, significantly reducing competition. One example is Microsoft Translation API, Z-code. The MOE architecture is Z-code supports a massive scale of model parameters while keeping the amount of computer constant. In as part of application of mixture of expert, computer vision perspective, Google VMOE, a sparse architecture based on the vision transformation and showcase effectiveness or of MOE computer vision task by partitioning images into smaller patches and feeding them to getting routing layer. MOE can dynamically select more appropriate expert of each patch, optimizing both accuracy and efficiency. Then comes uh, now moving on. Notably, advantage of this approach is its flexibility. You can decrease the number of selected experts per token to save time and computer without further training on the model ways. A recommendation system MOU has also been successful applied to recommendation system. For example, Google Research have proposed a multi-gate MOE based ranking system for YouTube videos recommendation. They they first group their task objective into two categories: engaging and satisfaction. Engagement and satisfaction. Given the list of candidates videos from the retrieval step, their ranking step system uses candidates user and context and features to learn to predict the probability corresponding the two categories of user behavior. One thing to note is in this approach is that they did not apply the MOE layer directly to the input because the high dimension and dimensionality of input would lead to significant more model training and serving cost. MOEs have been wide-scale adoption in the industry for several applications. The learning procedure divides the task into appropriate subtasks, each of which can solved by very simple expert network. This capability translates to parallelizable training and fast inference, making MOE a lucrative for larger scale system. As part of the training complexity, training MOE model more complex than training a single model, where so coordination, optimization, and hyperparameter tuning is followed. Inference efficiency and increase in model size. So all these are the things. When to use Deepseek AI MOE for architecture. So typically, if you want to, when we want to go for this, is so we would be uh, going in detail about when to use DeepSeek AI MOE architecture, scaling large language model efficiently during that time, then handling diverse complex tasks, optimizing inference speed and cost, training on large scale heterogeneous data, then enhancing model generations. If we go in detail, scaling large language models efficiently, MOE enables massive models like 100 billion plus parameters to be trained and run efficiently by activating only subset of total parameters as per forward pass. This reduces the computational cost of dense model of similar size. Then similarly for optimizing inference speed and cost. Then comes standard transformer architecture and comparing with MOE architecture. Structure perspective, consists of multiple identical layers with self-attention mechanism and feed-forward networks. Whereas in MOE, mixture of expert structure perspective extends the transformer by introducing multiple expert FFNs in place of single dense FFN. Then competition perspective transformer, standard transformer, every input token taken passes through all layers and neurons, making a dense model. Whereas in MOE, instead of using all expert, a router network selects only the subset. Example 2 out of 16 experts per input token. This makes sparse model. So basically, sparse model is more focused. Scalability, scalability perspective limited by computational cost. Adding more parameters increase memory and compute requirement significantly. Example per BERT and GPT-3 T5. Whereas in MOE, mixture of expert, scalability perspective more efficient than dense model. MOE can have hundreds of billions of parameters while using fewer envelopes as per token. Example models Deepseek MOE GPT-4 Turbo, then G-Share Sahara Switch Transformer. So these are the typical comparison of transformer and competitor, comparison with transformer and MOE based on computation, parameter scaling, efficiency, generalization, and memory usage. I- so MOE highly due to storing many experts. Then and comes to the final part. Just would like to uh, talk about this. If you need to revolve around search and retrieving data from specific domain or larger database data set, example enterprise data, scientific paper, legal document, and you need precision in retrieval, Deepseek might be more suitable. So that's the thing. And finally, concluding on this, in this article, we have explored mixture of experts, techniques, a sophisticated approach for scaling a neural network to handle complex tasks and diverse data. MO uses multiple specialized experts and a gating network to route input efficiently. We overheard, we covered the core components of MOE, including expert network and gating network, and discussed with training and inference processes. Benefits such as improved performance, scalability, and adaptability were highly highlighted, along with the application in natural language processing, computer vision, and recommendation system. Despite challenge in training complexity and model size, MOE offers promising methods for advancing AI capabilities. Okay, thanks for this session.